So because we can never have a 100% actual yield, we come to this idea of a percent yield. And it's literally, as its name implies, how much of a yield are we actually getting, or what fraction of the whole amount are we actually getting out. So this percent yield we can find really easily just by knowing the actual yield, or how much we actually found through experimentation, divided by the theoretical amount. So this is the portion divided by the whole entire amount, and we multiply that by 100 and we get our percent. In this example, we are reacting methanol and carbon monoxide. So the balanced reaction which is given to us, we have CH3OH plus carbon monoxide yields acetic acid, HC2H3O2. Okay? So in order to do this, we are going to need the molar masses. But what we're asked two questions. Question A, what is the theoretical yield of acetic acid and I'm going to abbreviate it AA. So what is the theoretical yield of acetic acid? And part B, or the second part of that question, is what is the percent yield? Of acetic acid. Now, in order to do that, we are going to need some sort of another piece of information, and that's actually given to us. But what we need to do first is we're going to need to figure out the theoretical yield of acetic acid. For this problem, we are given 15, so here's what's given, 15 grams of methanol, CH3OH, and we're also given 10 grams of carbon monoxide. So this is another limiting reagent type problem. So we'll go ahead and run through these real quick. Given these two, we need to figure out how much acetic acid we can actually make. So we always start with what we know. We have 15 grams of methanol, and we have 10 grams of carbon monoxide. We need to convert from grams of methanol into moles of methanol. So 1 mole of methanol weighs approximately 32.04 grams. Similarly, carbon monoxide, we're going to do the same move. 1 mole of carbon monoxide weighs, carbon's 12, oxygen is approximately 16, so 28, approximately 28 grams carbon monoxide. Okay. Now that we have moles of methanol, we need to convert from moles of methanol into moles of acetic acid. Looking at our balanced reaction, we know that we have a 1-to-1 ratio. So we're going to convert from moles of methanol to moles of acetic acid. We want acetic acid on top. So 1 mole of acetic acid over 1 mole of methanol. Okay. Same thing with carbon monoxide, where we have moles of carbon monoxide now. We need to convert to moles of acetic acid. Looking at the balanced reaction, we have 1 mole and 1 mole. So 1 mole of acetic acid is produced for every 1 mole of carbon monoxide that gets used. So we'll run through this calculation real quick. We have 15 divided by 32.04. We get 0.468 moles of acetic acid. And then 10 divided by 28, we have 0.357 moles. of acetic acid. Okay, so what we just did is we found the theoretical yield. At most, we can make 0.357 moles of acetic acid. So let's convert moles into grams of acetic acid. So for that, we'll need the molar mass. For every 1 mole of acetic acid, it weighs 60.05 grams. We actually do this math real quick. 0.357 times 60.05, and we get 21.44, approximately 21.44 grams of acetic acid. So that takes care of part A. The question is, what is the theoretical yield of acetic acid? We have 21.44 grams. Now, in order to do part B, we are given one piece of information which we actually need, which is actually necessary. That is that our experimental yield, or what we found through experimentation after actually running this thing, the experimental yield was 19.1 grams of acetic acid. So now, in order to find the percent yield, we literally just plug and chug between our actual yield and then the theoretical yield. I guess I should label that, huh? So this one is the theoretical. Ran out of room. That's our theoretical yield right there. And then this right here is our actual or our experimental yield. So to find the percent yield, all we do is take our actual yield or the experimental yield, 19.1 grams, and then divide that by our theoretical yield, which was 21.44 grams. Multiply that by 100, and we get 19.1 divided by 21.44 times 100. We get a percent yield of 89.1%.